This is just covering basically addition of vectors. So my goal is to show you a few different ways to actually add vectors, and then also kind of what it's actually meaning. So here we have three vectors, and it's basically asking sum these up and find the correct answer. So a vector is basically a direction and what's called a magnitude or a distance on a grid. In this case, we have two axes, which is really their imaginary axes, I and j, but you can think of them in many ways as x and y. So here we're going to have our I axes, and here you're going to have your j axes. And what this is telling is you have one point that's 5 units over on the right. So roughly, let's say right there, let's say that's 5, let's say that's 10. We'll do the same over here, 5, 10, 5, 10. So it's 5 units over, and then it's going to be 9 units up. So it's going to be roughly right here. But again, it's not just a point, it has a magnitude. So basically we have a line that goes up to that point, right? You have another point that's going to be 6 minus 3, all right? So the i's go about 6 over, which is going to be right here, and then it'll be minus 3 down. And again, you're going to have a point that goes, or a vector that goes in that direction. And then finally you have 2 and negative 12. So 2 is going to be here, negative 12 will be about there. So it's 3 vectors going like this. You can also think of, essentially you have a vector at this point, which is 0, 0, right? You have 0 plus 0, 0i plus 0j. And really all this line is the difference between this value and this point here, and that's what's getting you that. But a little bit deeper, this is actually what you're doing to solve it. So if we draw that same grid here, we'll draw our first vector over here. This was the 5i plus 9j. And you have a line that goes up like that, right? But then you take the next one, and you're going to basically add on to the endpoint this next vector. And that'll kind of come down at this angle. So if we were to copy and drag this one over, you get something that gets you right around here. And then finally, you're going to add on that last vector, which is doing something like this, right? So your final resultant vector is going to be looking like this dotted line here. That's all you're doing. You essentially have like these directions that tell you go this many units over, this many units up, and take the resultant hypotenuse of that triangle, if you will. Mathematically, it's very simple. You're just going to take all your I units, right here, and right here, and you add them up. So this is going to be 5 plus 6 plus 2. 5 plus 6 is 11, plus 2 is 13. So you have 13, comma, and then you take all of your j units. You have 9 minus 3 is going to be 6j minus 12. That's going to be negative 6, right? So again, this would be the point, but really you're looking for the vector, so it's going to be 13i minus 6j, okay? And if you look over here, this was essentially just past your 10 value, which is going to put you right at that 13 somewhere over here, and then minus 6, it's going to be just past that. So that looks about right. A little bit further than that, though, if we go to some code, just very basic code, how would this look in actual code? So what you first start with is, I do suggest starting with importing NumPy, since you're working with essentially an array, kind of a duplicate of a vector in many ways. But what we're going to do is create a list, and the list is going to be a list of these little lists, and the first one being this 5, 9. If we go back to this here, you have 5i plus 9j. That's going to be your first unit. Then you have 6, negative 3, then 2, negative 12. So again, going back, that's exactly the numbers we were dealing with here. We've put them inside of a single list because there's a NumPy function that allows you to quickly summate them in kind of this vector format. And that's simply numpy.sum. We've imported NumPy's NP, so it's going to be listed np.sum. and you import the list of vectors, and this tells you what axis you're working on. Axis 0 is going to be the rows, essentially. I believe it's the rows, and then 1 will give you the columns. Your output's going to be an array, and that will be your answer, 13 comma negative 6. Again, what did we get with basic math? We had 13 comma negative 6, or 13i minus 6j. If we dig a little bit deeper, that's a nice basic function that does it for you. But if you want to actually know what's going on in the background, you can kind of go through the basics. So since we have a vector list, to index it, you'll have two values. The first value is the list value. So this is list number 0. In Python, it'll start with 0. This would be list number 1, and this would be list number 2. The next value is the index within that list. So again, we have the 0th list with the 0th element would be 5. So that's what's showing here. We printed out 5. Then we can go into a for loop, and the for loop will allow you to do 2 indexes at once. So if I do for every I and every j, basically what it's going to do is print the I value and then the j value, and then it's going to go to the next one, print the I value and then the j value, and then the next one, etc. So we get each one of our vectors here printed out. That's just to show you what this is doing in the for loop. And then to actually add them up, we would create 2 values. We're going to start them with 0 because we're going to add to them. I'm converting I to the x value and j to the y value, because going back to our graphs, our x-axis, if you will, was an I, our y-axis was j. So I'm just going to use those to make it simple. I'm going to do that same for loop where I'm actually doing both sets within the same for loop. And for every time I hit I, I'm going to replace that value with the addition to itself. This is what the plus equals means. So what that gives me is x comma y, which will be our final value. If I tab this in, now it's going to print x, y every iteration. So now what you can see is the very first time I have 5 and 9. Then I'm going in and I'm going to take the 5, and the next value is going to be 6 here, and I add it to it. So I get 11, and the next y value would be negative 3. 9 minus 3 is 6, so that's my next row. And then finally I'm going to add 2 to the 11 right here, and I'm going to get 13, and then I'm going to add the negative 12 to 6 and get negative 6. So that'll show you each step along the way. That's what this plus equal is doing, is it's just replacing those values by adding them over. So vectors in a sense are just kind of directions. You're going to go so far in one direction, or essentially two if you think about it. Any direction has steps to the right and steps forward, or steps to the left and steps forward. If you're going straight forward, you've gone 0 steps to the right. If you rotate a little bit and then start going forward, you've gone several steps to the right and forward. That's what you're doing with a vector. The difference between the vector and the point is the point will tell you the final destination, but not necessarily where you started. And the vector is saying both where you started and the final destination. Adding them is simply just breaking any line into its 2 components, which is kind of like a triangle. Basically, you have any point here on our grid here has these 2 components, and we're breaking up each one of these components into their inherent triangles. Anyway, I hope that was helpful, and I'll have a few more of these up in the near future.